Hi, in this video I'm going to explain the first example of Riemann integral. Here I have the case I'm going to be integrating, and here is the interval we're going to be using for this purpose. I have here the set of formulas we're going to be using in this example, which are pretty well known. First thing, I'm going to identify in the interval which has A and B. A is always where you're starting, and B is always where you're ending. Now the second thing we got to do, we got to find the value for delta x. So let's solve this out. Delta x over here, and delta x is it's equal to b minus a. In this case, would be 5 minus 1 over n. So delta x is going to be equal to 4 over n. Now let's go for x of y. X of y. It's going to be equal to a. A is equal to 1 plus I. It's a very ugly I. Okay, there it is. Times delta x. Now delta x, we just found it. It's 4 over n. It's going to be over here 4 over n. There it is. We got our delta x and our x of I. So now let's get to the actual problem. So I'm going to start over here. So this is the summatory. From I, it's equal to 1 until n of f. Now f will be in terms of xy. So I'm going to actually use the same color. It will be here 1 plus I times 4 over n. It's very ugly, 4. That's better. Yeah, that's better. So will be here times the delta x. So delta x is already 4 over n. So I'm going to using 4 over n. Now let's keep working this through. This will be equal to the summatory, starting from I is equal to 1 to n of f of x. Now f of x is equal to this x plus 2. So let's see. Instead of this x, I'm going to be substituting this 1 plus I times 4 over n. So it will be like this. I'm going to use the same color. Be 1 plus I times 4 over n. I'm sorry. Over n will be plus 2. This is the f of x. Remember, this is the x, and this plus 2 stands from this f of x, which is this part. Just substitute the x for the value of x of I. Now let's see, we got to multiply all these by 4 times 4 over n. So I'm going to use a bracket. This is a bit messy here. It's bracket times this 4 over n, which is delta x. 4 over n. I'm using, remember, this formula here. This is the delta x, which stands here 4 over n. The f of x of b is this part. Substitute the x of b on f of x. So let's keep moving here. Okay, let's see. Be equal to, oh, this is a different color. There it is. Will be equal to the summatory starting from I is equal to 1 to n. Let's see, I can get rid of the bracket. So it will be here 1 plus I times 4 over n plus 2 will be times 4 over n. Now I'm going to multiply, I'm going to simplify here things. I'm going to add up this 1 and this 2. And this will look like this. Just for the purposes of making this simpler. This will be, I'm going to put first this I. So I times 4 over n plus 3 times the 4 over n. Now I'm going to multiply this 4 over n times this term plus this one times 3. So let's see. The summatory from I equal to 1 until, so let's see, it would be I times 16 over n squared plus 12 over n. There it is, looks nicer. So now I'm going to apply a distributive property. I'm going to apply this summatory to this term plus this summatory to this other term. So let's see, it would be like this. I summatory from I equal to 1 times the summatory from I times 16 over n squared plus the summatory of I equal to 1 until n of 12 over n. Now here I'm going to remember something here. This part, this 16 over n squared and this 12 over n, they are constant. They should be treated as constant. So I can apply this property of summatories of putting this one outside the summatory. And that's what I'm going to do in the next step. So let's write it like this: 16 over n squared times summatory of I equal to 1 until n of I plus 12 times n, over n times the summatory of I is equal to 1 until n of 1. Now I've just like splitted this term into 12 over n times 1. Now I move outside the summatory this 12 over n over here, just in order to fall. This one and this one are well-known formulas. The summatory of I, it's equal to this one. I'm sorry, here I forgot to write this. Should be I over here. There it is. The summatory of I, it's equal to this formula, and the summatory of 1, it's equal to this other formula. So we can just pretty much substitute. I'm going to do that in the next step. Going to be 16 over n squared times, let's use here a different color just to make sure what I'm doing. This one will be equal to n times n plus 1 over 2. Now will be plus, it's a very ugly plus, still ugly, there it is, 12 over n times the summatory of 1, which I'll be using, let's say orange, will be equal to n. There it is. I better use the same color, white. There it is. Now this, we can work with this through. So let's try to simplify things out first. I'm going to simplify these two. So I'm going to be using a different color. This 2 turns into a 1. Simplifying this by 2 will be an 8. This n will turn, simplify one of this, turning into a 1. This n will cancel out this n here. So I'm going to scroll down now the screen just to continue working with this exercise. There it is. I think that's enough space. So let's see. Let's continue with this one. Let's be equal to. I'm just first going to write it in a clean and ordered and nice way. 8 times all this will be over n plus 12. Now let's see what we can do. I'm going to multiply this 8 times this n and then plus times this one. I might be using a lot of steps. I think this is better for starting up. Over n plus 12. Now I'm going to divide these two guys, and these two guys over here. So it will be 8 over n, 8 times n over n plus 8 over n plus 12. It's a very ugly 12. God. There it is. So now here we can simplify things out. Let's simplify this one and this one, and then we will end up with this 8 plus 8 over n plus 12. Now we can add up this 8 and this 12. So it will look like this. Will be 20 plus 8 over n Now this one is where we are going to apply the limit. Remember, a Riemann integral is essentially a limit problem. So I'm going to use a white here over here. So we look at this. The limit when n, which is the number of rectangles, approaches to infinite. For this statement we got here will be 20 plus 8 over n. It's equal to so we're going to substitute every n by this infinite. Will be looking like this: 20 plus 8 over infinite. Now remember, any constant divided by infinite, this turns into a 0. So we got to this integral. It's equal to 20 units squared. Let's get scroll up here just to see where we started. So we started over here. This we were solving out this Riemann integral for this f of x integrated for this interval between 1 and 5. It represents the area below this function for this interval between 1 and 5 would be equal to 20 units squared.